So in this practice, integrate the following functions, t and t squares. So let's review the definite integrals. Definite integrals. Integrals, if you consider some functions, bt is a function of the t. Then definite integral set b as a function of t, and v can be drawn this way. And we'd like to find the definite integrals a and b, like this: a to the b, bt, dt. So this function is b equal ft. The definite integral, what's the meaning of definite integrals? A to the b is correspond to the areas under the curves between t equal a to the b. This is the definition of the definite integrals. So we'd like to find out the definite integral of the two functions. First one's a definite integral 0 to the 1 t dt. To find out the areas, we need to find out areas. 0 to the 1. This is the functions. b equal t. 0 and then 1. 0 and this is 1. And we'd like to find out the areas under this line. So in this case, this length is 1. This length is 1 because v is a 1. So you could easily find out area of this triangle. It becomes 1 over 2. This is definite integrals of the t between the 0 and 1. And the next question. 0 to the 1 t squares dt. Again, we can draw the curves. b equal t squares 0 and 1. Okay, also in this case, what we'd like to find is areas under this curve. But in this case, shape of area is not triangles. So it looks like it's quite difficult to discover these areas. But we consider that these areas can be approximated by a number of the rectangles. This rectangle. Each rectangle has the same length of the bottoms, delta t. Delta t is expressed 1 over n. Same length. Then you express the coordinate of the bottom of the left side of the coordinate is expressed I minus 1 times delta t. Then the height is expressed 1 minus I square delta t squares, because this point is on the b equal t squares. Then areas of these small rectangles is expressed delta s sub I is I minus 1 squares delta t square times the delta t is the bottoms, so delta t cube. This is a small area of the rectangle. Then we can approximate this equation. It is sum up all the small rectangles, area of the rectangles. I equal 1 to the n. Delta is sub I. These small rectangles. But in the definite integral said, if you increase the number of the divisions of the small rectangles, so this means n is go to the infinities, these two areas exactly same. Okay, so we call this is Riemann sum. Then the next question is we'd like to perform these calculations. So this is equal to limit n go to the infinities. I equal 1 to the n. So you can substitute this. I minus 1 squares delta t cube. Delta t is 1 over n. So we can limit n is go to the infinity 1 over n cube. I equal 1 to the n. I minus 1 squares. Now we would like to calculate this sum. So I'd like to write this sum. N I minus 1 squares. Then we'd like to change the variables. J equal I minus 1. Then this becomes j squares. But range is different. J equals 0 to the n minus 1. So j equals 0. You don't have to include j equals 0. J starts 1 to the n minus 1, j squares. Then you could calculate. You have a very famous formulas for these ones by really carefully. This is n minus 1. Then it becomes n minus 1 n 2n minus 1 over 6. Then you can substitute this into these equations and divide it by the n cubes. Then it becomes limit n to the infinities 1 over 6 1 over n 2 minus 1 over n. So it becomes limit n go to the infinities 1 over 3 minus 1 over 2n plus 1 over 6n squares. Then you can move the n go to the infinities. It becomes 1 over 3. So finally, we could discover the areas under this curve is gonna be 1 over 3. So the answer to the second question is that t squared dt is 1 over 3. Okay, this is the answer to this question.